and welcome to the XP Solutions XP Live webinar entitled What's New for 2014. My name is Colby Manwaring, and I'm the president of XP Solutions. Today's webinar is an exciting opportunity to announce some of the great new features in our version 2014 products and see some of the things that might enhance your day-to-day work and the delivery of your projects to your clients. A brief bit of history about XPSWM and XPSTORM. Many of you will know that we first released these products 17 years ago now as graphical, hydrologic, and hydraulic modeling tools to enhance engineers' abilities to design and simulate and visualize drainage systems, combined sewer systems, riverine systems. These tools have been used now, we're coming up to 2 decades, which is seemingly beyond belief for many of us. 17 years ago we started. Then in the year 2005 we introduced XP2D for flood modeling in an integrated 1D, 2D modeling environment. This approach has been hugely popular worldwide, and we know that especially in Australia, New Zealand, in this region of the world, this has filled a demand for many of you as you are doing high-level flood modeling. Today, XPSWM and XPSTORM are used by thousands of users around the globe. We have today a lot of new features that you'll see, and we hope that you'll recognize that many of those features are requests from you, our clients, and the users of our software. We have a passion for listening to the engineers and the planners and the people that are out in the market using our software, and we enjoy hearing your feedback on what we might do better and the features you'd like to see. We try to take each one of the comments and suggestions to our development team and improve our software each year so that your experience and your productivity is increased every year. Now today I'm going to hand over to our main presenter. Jessica Jeffries is the XP Solutions Product Manager for Australia, New Zealand, and has been with XP Solutions for approximately 7 years, originally starting in our UK office and now in our Brisbane, Australia office. Jessica has been the main lead in showcasing our products to the Australia, New Zealand region. She will be going through some of the new features, both talking about them and demonstrating those things today. With that, I will stop talking and let Jess start talking. Jess, please take it away.
Thank you very much, Colby. So as Colby mentioned, this is one of our webinars that you're joining us today, and this webinar is part of our XP Live educational program, and this means that it will go onto our website along with all our other recorded webinars available at www.xpsolutions.com. Today's webinar will be less than an hour in duration, around about 30 to 45 minutes, and we'll be talking about the new features in the 2014 release. We'll do that with a combination of presentation and with some live demonstration in the software. And there's a lot of really exciting, significant enhancements to the software, in particular some sewer modeling enhancements, river modeling enhancements, GIS and 2D modeling enhancements as well. And of course we've got the question and answer session going on throughout the whole presentation as well as at the end. Importantly, this release is free for our existing Expert Care customers, and you can access that by going to the support portal and downloading the latest version of the software. The support portal always has the latest version of the software, so it's the best place to go to access the software. And if you're not under an existing Expert Care contract, feel free to get in touch with us, and we can help you to get onto expert care. So first I'd like to just very briefly recap the 2013 enhancements and new features. Hopefully a lot of you have been using these features over the last year, but just a reminder, we did some work in preparation for the river modelling, importing HECRAS and bridge links. We did a lot of 2D updates, big update to the results data set and the speed improvements, and also some other GIS updates. So on to the 2014 release. Well, obviously we don't have enough time to go through all of the enhancements today. Here's a selection that we are going to talk about. And first we'll look at some of the sewer updates. Then we'll move on and look at some of the river updates and into the stormwater and flood modelling updates at the very end. So in 2014 we've made some improvements to sewer modelling, and we've put in a new template, and this template means that when you start the software we have more than 30 changes to your standard XPSWM and XPSTORM. And that means that it's going to save you time, be more efficient when you start a model. So you've got setups in the database such as conventions to the manhole naming, tables set up for sewer modelling, and other adjustments to the interface so that you don't have to view the river modelling section and the 2D modelling section. And this also locks some of the non-sewer features, so it just means that you're not going to accidentally use them. Importantly, we've also made an update to the way you can enter dry weather flows into your sewer models. Previously we were able to have multiple dry weather flows only with a series of workarounds. So in 2013 it was only possible to have one. Now it's possible to have multiple dry weather flows, and this is a really nice feature to allow you to model per land use or based on other socio-economic reasons that would require you to need multiple flows. And this is located within the node data in the hydraulic layer of the software, the hydraulic mode. You can select dry weather flow, and when you open that dialog, instead of going straight to the dry weather flow generation, you now have the option to set up multiple dry weather flows. Once you've set these up, you can reuse them and select which ones you want to use. We've also added some additional data fields. It's now possible for nodes and links to have a material, a year, and a zone. This is really important for sewer modelling, but also applicable to other areas of modelling. It's also useful for stormwater modelling to record the material. When we say year, we're talking about what year was the pipe or manhole or pit installed. It's really a good way to track asset management functions. And because of our links with GIS and other databases, this data can be carried through and out of the software. As well as allowing you to put this into the nodes and links, it's available in XP tables as a variable to be displayed, which means you can sort the data and query the data in XP tables, again providing more functionality that supports asset management. And positioning it in the XP tables database also means we can import and export this data through our usual range of connections. So moving on to the river, storm and flood modeling side of our new features and enhancements. We've got several features here that have been highly anticipated and have built on functionality from the 2013 release. So in 2013 we had HECRAS imports for the geometry, the cross-sections from our rivers, but now we've added the ability to import bridges as well. And we've built in a new modelling feature called river reaches. Essentially this means your open channel modelling can be streamlined and simplified when you're building a river. So we've identified the areas, the aspects of the dialogue that you'll want to use to enter open channel data, and got rid of the closed channel dialogue so you don't have to deal with that each time you're modelling a river. The 1D 2D interface line tool also now has the ability to identify the elevation and automatically adjust it. We'll go into that into more detail. We'll look at the 1D pipe network side of things and how we can show multiple hydraulic grade lines on the profile view. And then in the 2D modeling side of things, we've got some added post-processing capabilities and the ability to set up user-defined hazard criteria. So we'll show you how to do that. So first, the river reach layer and links. This is a new layer in the program, and it allows us to build rivers directly from scratch or to import river models from a program like HECRAS into this layer. So we can use this link to create river sections, label the river sections, and easily identify these rivers within our model. We've also identified this with the specific blue markers, which means we can easily pick this out from the software. And on the layers side of the software, we have the river layer, and we have the ability through that to convert links to a river layer, and we have different properties for these river links. So we can, once we've set up the river link, we can also convert it to a bridge link or convert it back to a non-river link, so it's not a permanent change. With the bridge links, as I mentioned, we've now got the ability to import from HECRAS, and this supports the single and multiple openings and is a really easy to use interface in order to set up the bridge directly. So you don't need to use multiple links anymore. You can actually specify the piers and the different openings, and those will be imported directly from a HECRAS model and identified. So we'll go to the software for our first section of demonstration, and here we have a model which has some of the nodes and links set up as pits and pipes closed channels. We've already converted part of this model to a river link, and that means it's identified with the blue dashes. And in our layers here under our new rivers layer, we've got two sections of river identified here. If we open one of these links, we go straight into the river link data dialog, not through our usual link dialog. So we're just getting rid of one step there. And we've added onto this dialog a HECRAS input. So we now have options to import the HECRAS file from the file menu and from within the link, the river link dialog. We can easily convert existing links to a river link simply by selecting them and if we right-click on the river layer, we have the option to convert these links to a river. When we create a river, we need to give it a name. So I'll just put in the name here. So that's now being converted to a river link. We could also use our new tool, the river tool, on the toolbox to the right hand side, and simply draw new river links. And that creates another section of river within the layers. By right-clicking on each individual river section, we can select the objects within that and edit the properties, as well as directly accessing the long section view. So it just gives us an easier way to model rivers, saves time, is more efficient, and also makes it really easy to identify any rivers that we do have within our model. So moving on to some of our other enhancements and new features. The 1D 2D interface line is a really important part of any 1D 2D model. When you link 1D open channels with a 2D floodplain or 2D mesh, the interface line is where the exchange of water occurs, and this boundary is really critical for creating a good sound 1D 2D model. It can be a place where instabilities can occur and where we receive inquiries into 1D 2D models about what's happening along that boundary. So we've created a way for you to inspect your models and actually get visual feedback as to what's happening along that boundary. So this new profile view means we can look at any particular section, look at the flow line along the 1D and 2D interface line, and actually see what the levels are doing along that line. So this profile view shows us first in blue. We see the bed elevations, or the bottom of the river. Then along the green line we have the top of bank elevations. So this shows us the top of our 1D cross sections, if you like. Then in red we get to see what is happening with the 2D, with the surface along this interface line. And you can see in this example it's not ideal and not what we would expect. We wouldn't want to see the 2D surface ideally too far from our bank elevations here, and in particular with such a dramatic drop in this case, it shows how far off the actual values in our 1D model we are with those 2D levels. So because this gives us some feedback about whether we've set up the model well, or whether those interface lines have been well set up, we've also put in some tools to allow us to fix this. And one way we could do that is to actually create a ridge line, a break line essentially in our 2D surface, and force the 2D mesh to follow the 1D profile. And we can do that either by bringing those 2D elevations to match the top of bank, or to match the bed elevations. So there's two buttons on the form that will allow us to automatically create those break lines or ridge lines. Of course, you can also use this simply as a flag for you to then go and investigate this particular area of the 2D surface and manually make any adjustments that you might want to make. In conjunction with this and similar along the same lines, we've got an enhanced dialogue for the ridge and gully lines. And again, we're looking to give you more feedback, more visualization of what's happening in the software. So previously, when you added a ridge or gully line into the software to edit the surface or the DTM, you were just entering data into a table. And now what you get is you actually get a graph plotted to show us what adjustments are being made. So our green line is showing us our existing DTM surface, and then in this example here we put in just a simple 2D break line with a constant elevation, and that's shown in blue on the graph. We also have the option to put in a 3D break line with varying elevations at different X and Y locations along that line. And again, we get the feedback from the graph here. And when we do this, we can use tools to modify the elevations, and we'll actually show you how to do that in a model. So it's really nice to just have these features to be able to see what's actually going on in your model. I'll go back into the software now, and we'll just use this example here where we've got a section of 1D river channel within a 1D 2D model. We already have the ability in our 2D model job control to actually make checks along the interface and either ignore what's happening if there's differences, report errors, or make automatic adjustments. Putting in this extra interface to report back the profile along that 1D 2D interface line just gives us another layer of reporting and diagnostics. So I've selected this 1D 2D interface, and I just right click and choose the option to display the profile. We have a warning pop up, and this warning tells us that really our 1D 2D interface needs to be better located to follow the inverts or the bank of this particular open channel, and it's suggesting that we use one of the tools available to help us resolve this issue. I click OK to the warning. It doesn't make any adjustments for us yet. We just get to look at this profile now and decide actually what's going on here. So similar to the example we looked at before, we've got a very different surface than our 1D elevations at the bank or at the bed at the invert of the channel. So we could click one of these buttons or go and just interrogate the 2D surface and see whether we want to make any manual adjustments to the interface line here. Now we'll just look at the ridge line and actually see how we would manually create a ridge line and look at the additional graph in that sense as well. You may have used some of the features under the topography layer before. Obviously this is where we load in our 2D surface, our DTM. But if we right click on the topography, we have the ability to add some other layers, and these layers, just a reminder, allow us to change that 2D surface and are particularly useful for 2D models. the gully and ridge break lines are where we've made improvements for 2014. So I'll select the gully ridge line, and that adds a new layer into our layers panel here. And what I'm going to do is just use the polyline tool here. If we imagine we wanted to put into this model a levee along the edge of this channel, then we can simply draw onto the surface the line that we want it to follow, and I've just double-clicked to finish that line. Our graph's a little faint, so I'll just change the style there to be slightly thicker. So this shows us what's going on the DTM along that line that we've drawn automatically. We can choose the 2D or 3D break line, and then we could enter these elevations one by one, or we also have the option to put in a starting and finishing elevation and choose the interpolate elevations option, and that's just interpolating between those 2 points at every point along that line. Once we've done that, we can still use the tool here to offset that. So if we decide we want a little more protection from this levee and we want to increase that by 1 meter, we can apply the offset, and it applies to the graph. And because we have the graph there for immediate feedback, it's very easy to see what we've done in the model and see what's actually happening. So hopefully you'll find that a useful tool. I'll go back into the slideshow and move on to talking about the enhancement to our profile views, our long section views. And it's now possible to review multiple storms in the profile view. So previously we had the ability to view one profile view, and now it's possible, one hydraulic grade line, and now it's possible to view multiple hydraulic grade lines. And I've got an example again to show you this in the software. And here we've got a model which has been run with global storms. So I've selected multiple links, and I'm going to view the dynamic long section view there. The first view we get is just of one storm, but if I use the drop down up here, we can now run through not just each storm individually, but select all storms. We have a little legend at the top here just telling us which color relates to which of our global storms, and we can see the different colors marked on the long section. We can still use the animation, and one other new feature in 2014 is the ability to loop the animation. So this means it'll just keep going through over and over again, particularly useful if you're trying to look at a short storm and see what's happening. So now moving on, we don't have time to look at all of the enhancements we've made to for 2D modeling, but I wanted to talk about these ones because these are ones where we've really listened to user feedback, and it really enhances what you can offer in terms of post-processing within the software. So we have a new tool for 2D results post-processing, and it's available from the Tools menu and is called the XP2D Utility Interface. And this allows you to take 2D results and create GIS files or to take multiple sets of results and compare them, and also allows you to convert between different 2D results formats. So the XMDF format is a 2D results format that we switched over to last year. It's more compressed and easier to extract data from than the previous format, which was the DAT file. So the first tab allows you to switch between these two file formats, because we know that sometimes you need to deal with a previous format for backwards compatibility, or perhaps you're opening an old job, an old model, and you actually want to update it to the XMDF format. You can simply choose the two files, switch between them, and select which output properties you want to convert. The next tab allows us to extract 2D results from our XMDF file, our input file, our input file being our results file, and save them in different GIS file formats. We still have the option to right-click on the results layer and extract the data. However, this tool provides a second way to do this. So it also allows you to pick a different set of results from the results that are loaded into the interface, and you can choose which format you save to, which GIS format, and also which results output. Then finally we have the option to create 2D results difference maps. So this means we can compare between a scenario where we have a levee breach and where we don't have a breach, or where we have a base case with a mitigation option, and we can create an output file for those for the difference, and actually look at the difference so we can see where the depths have increased or where the velocities have increased. So these options just allow you to more quickly and easily analyze some of your 2D modeling results, and also bring some of the post-processing that you may have needed to use other software packages for previously to within the XPSWM interface. We'll have a quick look in the software just after I've looked at a final feature. And that's the ability to create a user-defined hazard criteria. So previously we have had the option to select a number of different hazard criteria that are hardwired into the software, and these options still exist. You can still choose any of these built-in hazard categories. However, with constantly changing regulations and guidelines, there will always be hazard criteria and schemes for calculating hazard that aren't already loaded into the software. So we've put this new tool again under the Tools menu, and it's in a section on results post-processing. And we can apply a hazard scheme or a hazard value, so I'll talk about the difference between those two. With the hazard schemes and the hazard values, both of these can be saved within the global database as part of the templates. And this means that once we set this up, we only have to set it up once. We can save it and reuse it. And we see tables such as the one shown here appear in guidance documents, and so it's a case of giving you the flexibility to just set up all those different hazard calculations. So first, for the hazard scheme option, in this example we've actually used the Queensland Reconstruction Authority hazard classification scheme, and this is supplied to you in the 2014 release as a template. So it's already set up. This is the dialog that we use to set up the hazard classification, and you can see here that we can add multiple different categories that a scheme might have, so low hazard, significant, high and extreme in this case, but we can choose what those labels are. Then we set up the conditions, so when is this hazard category for this particular scheme met, and we can have multiple conditions, so it can be very complicated or very simple, just depending on exactly what you need to input. We've got the option of using depth, velocity times depth, and other conditions in order to set this up. And again, we've put in a graph so that you get some feedback. You can see when different values are going to be chosen. And this is stored away in the global database, and it's a case of selecting the hazard scheme you want to run, choosing which data set you're using, and then clicking apply to actually run that the hazard criteria. With the hazard value option, it's a little bit different. Rather than putting in categories, we actually produce a value, a number. So it gives us a measure of hazard. And an example shown here is a particular equation which combines depth, velocity and a debris factor to actually put a measurement on the hazard or the risk. So it means we can use an equation, or we can use a scheme where we have different categories or levels, and both of these produce mapped outputs that we can view within the interface. So finally, I just want to mention that because we've given you the ability to use debris factor within a hazard equation, we've put this into the land use database. So debris factor is normally associated with a particular type of land use, and if you have a hazard equation that refers to the debris factor, then you can actually set this up within the land use and show at different depths what the debris factor might be. So we'll go very briefly back into the software and just look at these tools that we've just run through. So we've got a 2D model here with our usual 2D maps and results produced. So if we go to the Tools menu and first into the XP2D utility interface, we can see here if we wanted to convert the files from XMDF to DAT file, we just choose our input file, we choose a name for the output file, and then we have a choice of the variables or the types of output within there to select, or to convert all types. And we just would click the execute button in order to do that. Similarly, on our 2D results to GIS, we select the input file, and the input file is either XMDF or DAT. We also need to reference the .2dm file. So that's produced when you run the analysis, so we have to locate that file as well, and then choose a name for the output file. And the options you have for saving the GIS format, so shapefile, the grid file, the ASCII grid file, and the map info file. So it's the same as you normally access through the right-click menu. And again, we can choose whether we do this for depth or velocity, and whether it's the maximum time step or all time steps. Finally, on the 2D results difference, again, here we just have the option for the XMDF or DAT input file. We do have to have the .2dm file located in the same directory, But here we select two files, put in the output file, and again we're just going to select which variable we're actually comparing, and it will produce that comparison file for us. So very quick and sort of simple interface to interrogate our results in a bit more detail. Moving on to our results post-processing. So if we first look at the hazard scheme option, so here we have the template file already loaded into this model for 2014 with the Queensland Reconstruction Authority. We could do that if we've got an old model that we want to add this to simply by clicking the merge option and choosing merge global databases and locating that template file. I'll just go back into the interface here and select that one. If we click on edit and edit again, it shows us here the different categories that have been set up and the conditions, and we can plot that on the graph. I'll just set up some axes quickly and update the graph, and we can see now a bit more clearly some of our conditions. So our first condition is that depth is less than 0.5 meters for our low hazard category. So that's how we define the low hazard, velocity less than 1.5, and the combination of the two less than 0.6. So we've done that for each of the different categories in order to actually set this up. And essentially that's taking the information from the table and turning it into a graph, turning it into something that we can run the analysis on. So we click OK to that and select that one, and then we have to select the engine results. We have to see which results are already available. So we've called the variable depth. We now need to select from the engine what that actually relates to, which data set. So depth obviously relates to water depth and velocity relates to velocity. And then it's simply a case of clicking apply, and it goes away and runs that analysis for us. It takes a bit of time because it's doing the post-processing on those results. Thank you for joining us today, and thanks for listening to the XP Live webinar.